Hello YouTube, welcome to Cloud Expert channel. Hope you all are great and doing fine. Today I would like to discuss about AWS Inter-VPC Connectivity Solutions and what are the problems of VPC peering that can appear and how we can resolve those using a transit gateway solution. Without further delay, let's get started. So first, I would like to bring everybody in the same space and I would like to explain what is VPC. I'll not take much time on that one. So you all know VPC is a service that lets you launch AWS resources in a logically isolated network. You have complete control over the virtual network, including selection of IP ranges, maybe creation of subnets, how many subnets you want, also configuring route tables and many other control you can implement on your VPC. Now, in your organization, you might need multiple VPCs. Now, let's see why you need multiple VPCs at first place, right? Maybe you want to separate the infrastructure based on the department. Maybe in your company you have finance department, HR department, admin department, and you would like to segregate their resources in a logically isolated network. And you want to monitor the cost of each and every uses. Or maybe you want to separate infrastructure based on environment. Maybe in your organization you don't want the resources used for production should not be mix and match with the resources with development or maybe testing. Or maybe your organization is supporting multiple customers and you want to keep logically separated network for each and every customers. So now we understood that we may have different use cases for which we may have to come with logically segregated network components, which is called VPCs. And since you are working in a single organization, there might be use cases where you want to minimize cost of some common resources. Maybe you don't want to share all the resources in the VPC, but you want to share only one or couple of share resources between the VPC to reduce the cost. That is why there may be cases where you have to connect between two VPCs. And when you are connecting to VPCs, the first option we have the VPC peering connection. With VPC peering connection, what does it mean? It means that you are connecting two or more VPCs. It could be on the same account, or maybe you want to connect from different account, or maybe you want to connect two VPCs in different region. And with that peering connection, which will enable you to route traffic between them either using IPv4 or IPv6. Using VPC peering connection, you can connect VPCs in different regions also, as I told. Now, how do you establish the peering connection? Let's say in my example, I have two VPCs, VPC A and VPC B. So here you can see I have VPC A and VPC B, and I would like to connect VPC A and VPC B with a peering connection. So first what I'll do, I'll initiate the peering connection from VPC A to B, and then from VPC B I have to accept that connection. When I'll accept that peering request, what it will do, it will give me a dedicated peering connection between the two VPC. Now instances from VPC A will be able to communicate or will be able to connect VPC B provided I have updated both the route tables in each VPC. Now I would like to focus or I would like to say couple of points that you should remember for VPC peering. The first point is that there should not have any overlapping CIDR between the two VPCs you are going to peer with VPC peering. If you see in my example, VPC A has a CIDR range of 10.0.0/16 and VPC B has 172.31.0.0/16. You may have used multiple CIDR block for VPCs, and every CIDR block should be distinguished, or there should not be any mapping CIDR between the two VPCs. Second is, as I told earlier, you have to update route table in each VPC to complete the VPC peering connection. Let's say you initiated that peering connection and you have accepted from the other VPC, but you haven't updated the route table in both the VPCs. In that case, you won't be able to establish connection from VPC A to VPC B. The third point is that peering connection can work inter-region and cross-account. So this is one important point, that you can establish peering connection between VPC not only in the same account, same region, but also from a different account from a different region. And the last but not least point, and that is very important, VPC peering connection is not transitive. What does it mean, a transitive connection? Let's explore together. So let's say in my organization, I have three VPCs, VPC A, VPC B, and VPC C. What I have done, I have established VPC peering connection between A and B and peering connection between B and C. But there is no dedicated peering connection between A and C. Now, on a high level, you can see that A is connected to B and B is connected to C. That means C is connected to A via VPC B. Now, if I would like to ping from one instance in VPC A to VPC C, will that work? The simple answer is no. Since it does not have a dedicated peering connection, you won't be able to establish any communication from VPC A to VPC C, no matter if the other VPCs are connected. So to establish communication between VPC A and VPC C, you need a dedicated peering connection. That is what VPC peering does not support transitive peering. Now, let's see another one concept. If I'll try to elaborate my previous example where I have VPC A, VPC A, VPC B and VPC C. Now, if you see carefully, VPC B and VPC C has a overlapping CIDR. So both the ranges are common. But VPC A has a different CIDR. So with VPC peering, I won't be able to establish any peering connection between B and C. But it does not stop me to establish peering connection between VPC C, VPC A and VPC B to VPC A, right? Because both of them does not have a overlapping connection. And now let's say I have established a peering connection between VPC C and VPC A, and on the other hand between VPC B to VPC A. And my requirement is that I have to establish connection to only a specific instances in VPC B. Although the 10.0.0.77/32 exists in VPC C. Now, how I will be able to establish this connection? Because with normal VPC connection peering routing table update, if I will try to establish or ping that connection to 10.0.77.32, VPC A won't be able to understand where should it send the response, to VPC B or to VPC C. For that one, we have to modify our route table in a bit different way. Now, if you see from VPC A, the VPC A route table, all the destination to IP address 172.16.0.0/16, that means all the local route, it will target to VPC A. But if any traffic for that specific IP, if you observe it carefully, /32, That means here I am mentioning only one IP address, and the target is peering connection between A and B. And any traffic for 10.0.0/16, it will be to VPC C. And now from VPC B route table, all the local route will be routed to VPC B, and any traffic to 172.16.0.0/16, it will be routed to peering connection between A and B. And similarly, for VPC C route table, any traffic on the local route, it will be routed to VPC C, but any traffic for 172.16.0.0/16, it will be routed to peering connection between C and B. If we will update our route table like that way, then our VPC A will be able to establish connection to the specific instance to VPC B, not to other instance. My friend, remember that one. VPC A will be able to establish connection to the specific instance. Any other traffic will be routed to VPC C. This technique is called longest prefix match, because here we have used /32. That means this is the single IP address. So if you see, longest prefix for 10.0.0.77, it would be /32 address, and it will have precedence over any other route in the route table. So if you see in the VPC A route table, if there is a traffic for that longest prefix, it will take the precedence, and it will go to VPC B instead of VPC C, although the same IP address may exist in VPC C. So I believe now the longest prefix match, this concept is clear. Next, let's see another one VPC peering limitation, that is no edge-to-edge routing. And I have couple of scenarios to explain what does it mean edge-to-edge routing. Let's say I have two VPCs in my cloud, VPC A and VPC B, and I have VPC peering connection between A and B. Now I have a on-premises network, corporate network, and I have established a VPN connection between my corporate network and VPC A. Since VPC peering does not support edge-to-edge routing, from corporate network you won't be able to reach to VPC B, although there is a dedicated peering connection between VPC A and VPC B. That is scenario number 1. Scenario number 2, let's say you want to create a egress only internet VPC. Means, let's say in each and every VPC, if you want to place NAT gateway, internet gateway, so you know NAT gateway has charges, so it will increase your total networking cost. But if you want to create one network that all your VPCs will be connected to a central VPC where you will put a NAT gateway, and all the outgoing traffic will be routed via that internet gateway or NAT gateway, then if you want to achieve that solution using VPC peering, it will not work. So that is what I tried to explain here. Let's say you have a dedicated connection, VPC peering connection between A and B, and you have an internet gateway in VPC A. Now if VPC B wants to use that internet gateway, it will not be able to access internet via the internet gateway in VPC A. And the third point is that, let's say you have a dedicated VPC peering connection between A and B, and you have established VPC endpoint in VPC A, and if you want to now connect, let's say S3 bucket from VPC B, you won't be able to, because peering connection does not support edge-to-edge routing. And now let's see another one problem. Let's say you have a, or maybe in your organization you have 4 VPCs, although in your actual organization you may have more VPCs, but just for simplification of the diagram, I have assumed, let's say you have 4 VPCs. And if you want to establish communication between each and every VPC, you have to establish dedicated peering connection between each and every pair. Now let's say you want to connect one AWS Direct Connect gateway with all your VPCs. So again, you have to establish dedicated connection between the Direct Connect gateway. On the other hand, let's say you want to add a VPN connection, maybe with a customer gateway. So what you have to do? You have to connect all the VPCs. Now you understand the mesh network with only 4 VPCs. Now let's say you have to add 1 or 2 more VPCs. So now you understand the network connection, right? So it will be a nightmare. More and more VPC will come into picture, and you can easily understand with the help of peering connection, your organization will not be able to sustain the network topology. It will be nightmare for maintenance. Now what is the solution? To summarize, what we saw, there is no transitive peering between VPC to VPC, right? Second, we saw there is no edge-to-edge peering. Third, we saw the messy network topology. And then, what is my solution for all those problems? That is why AWS came up with Transit Gateway. And now let's see how Transit Gateway will resolve your problem one by one. Now, this was your previous network topology with all the 4 VPCs. And for the time being, let's remove all the connections and keep only the components. Now let's see how a transit gateway will solve the nightmare. What you have to do? You have to provision one transit gateway per region. One transit gateway per region. And what you can do? You can create hub and spoke model. So you can see with this hub and spoke network topology, your connection topology become much simplified and it is easy to control. Tomorrow, if you want to add, let's say 10 VPCs, simply you have to connect with the transit gateway, and then your direct connect gateway, customer gateway, every component will be able to communicate with the newly added VPC. Even the existing VPCs will also be able to communicate with the VPC. Again, you have to update the transit gateway route table, right? But you don't have to create dedicated connection between each and every pair. So what is transit gateway? As per AWS, it is saying transit gateway is a highly available and scalable service to connect multiple VPCs. So if you provision one transit gateway, you don't have to think for high availability. So if you have to do, you have to provision one transit gateway per region. It will be high available and scalable. No matter how many VPCs you want to connect, it will be able to connect. It will be able to support your network topology. Now let's see some benefits of AWS Transit Gateway. The first is easier connectivity. What we saw, that Transit Gateway will act as a cloud router to simplify your network architecture. As your network will grow, the complexity of managing incremental connection will not slow you down. You can add more and more VPCs without even thinking to update, or without even thinking to connect between each and every pair of components or VPCs. Second, improve security. Traffic between VPC and transit gateway always remain on AWS global private network, and it will not be exposed to public internet. What does it mean? That since it will not expose to public internet, DDoS and other network exploits will not affect your connection. And again, if you want to connect transit gateway between regions, the transit gateway between region peering, it will have encrypted network connection. So your network topology will be have much more secure. Third is better visibility and control. With Transit Gateway Network Manager, you can easily monitor your VPC and each connection from a central console. And fourth, flexible multicast. Transit Gateway support multicasting. That means you can distribute the same connection to multiple destinations, and it will eliminate the needs of expensive on-premises multicast network devices. So this is very vital point. I believe, if I am not wrong, AWS Transit Gateway is the only networking component which supports multicast. Now let's see some use cases what you can achieve with the help of Transit Gateway. First, global sales application. Let's say your organization is spread across multiple regions. Maybe your organization has presence in US East, maybe US West, or maybe AP Southeast, right? As I told, you have to provision one transit gateway per region. Now you can establish peering connection between each transit gateway in each region, and you will have total end-to-end connectivity between each VPCs in different region. So for this connection topology, what you have to do, within a single region you will have one transit gateway that will support hub and spoke model, and between inter-region you will have transit gateway in each region, and you will have a transit gateway peering connection. So now you can see that how your network topology will be simplified with the presence of AWS Transit Gateway. The next is scalability and traffic management. As you saw in the previous diagram, so the diagram in the behind the scene, what you are doing as your network topology grows and grows, the incremental connection, it will not slow you down. If you want to add 2, 3 or 4 VPCs at later point of stage, what you have to do, you have to just connect those VPCs with transit gateway. You don't have to maintain dedicated connection between each pair. Then we can achieve better fault tolerance. Let's say you have couple of VPCs in one region, and you have a transit gateway which connected those VPCs in a hub and spoke model. On the same time, let's say you have a on-premise network and you have a direct connect gateway for a consistent network connection, right? And you want to establish a VPN connection, side to side VPN connection, as a backup path. In any case, if your direct connect went down, your VPN connection will work as a temporary solution or as a high availability option. Now, without the transit gateway, what you have to do? You have to set up different network component for direct connect and for side to side VPN. Now, AWS Transit Gateway support both direct connect and side to side VPN. So what you can do, since transit gateway is high available in nature, you don't have to provision multiple transit gateway. You can terminate your direct connect gateway and the side to side VPN both on the same transit gateway. And what it will do, it will reduce number of network component in your network topology, and it will give you a better fault tolerant between your on-premise network and the cloud infrastructure. Then what you can do, you can do edge to edge peering also. Now what we saw in the scenario number 2, your goal was to create one egress only VPC. That means all other VPC from your organization will use that VPC for internet connection, because if you want to install NAT gateway in every VPC, it will increase your network cost. With the help of VPC peering connection, we saw that was not possible. Now let's see how Transit Gateway will resolve that issue. Let's say you have account 1 and account 2, and in those account, for simplicity, let's say you have one VPC, but as I told, you can have multiple VPCs also in those account. And you have another one account, networking account, where you have a transit gateway, and you have created one egress VPC where you have created a NAT gateway and you have an internet gateway. Now, if you establish the route table in the transit gateway, both account 1 VPC and account 2 VPC will be able to use the transit gateway connection to use the networking account net gateway and internet gateway to access the internet connectivity. What we are doing, we are reducing number of NAT gateway, as NAT gateway is getting charged per hour. Having said that, although transit gateway will have a charge, transit gateway is not free. But if you have many accounts, placing NAT gateway in every VPC will be much costlier than placing one single transit gateway. So the problem what we saw in the previous H2H network limitation, that is also getting resolved with a transit gateway. And last point I would like to mention, with the help of transit gateway, you can isolate VPC with shared services. Let's say you have a network topology like that. You have 4 VPCs, let's say VPC A, VPC B, VPC C, VPC A, VPC B, VPC C, VPC D, and VPC D is your shared service VPC. And you have a on-premise connection also. Everything is connected to transit gateway with the help of a transit gateway in a hub and spoke model. And here you want to achieve that, let's say VPC C and VPC B will be able to connect to VPC D, but VPC A will not be able to establish any communication to VPC D. That also you will be able to achieve. How you can achieve? You have to modify the transit gateway route table, or maybe if you have to remove the route of VPC A, okay, then you will be able to achieve that communication. So you can see, with the help of transit gateway, although you have a hub and spoke model, there also you will be able to add limitations, which VPC will be able to communicate with which and which VPC will not be able to communicate with which. So here also you will be able to specify the connection restrictions with the help of transit gateway route table. I hope this entire part was very informative for you, and I hope I was able to give you some new information. Thank you very much for your support. I would request you, please like, subscribe and share my effort, such that others will be able to get benefit with that information. If you would like me to cover any other topic, please let us know in comment. I'll create a session to cover that particular topic. Thank you again, and please like and subscribe. Bye bye. Stay safe. Take care.